Hi, welcome back to Intermediate Algebra. Today we're looking at section 5.6, Applications. So we're going to be doing story problems here with rational expressions, and that's of course going to be loads of fun because I know everybody, story problems probably not your favorite thing. So there are steps for story problems. We've seen those in the past. So if if you don't remember them, go back and look at one of the other sections where I lay out those steps. So I'm just going to kind of jump in right here. The first note is, though, if you are taking this as one of my classes, for the homework, stop at number 17. If you're not, then just enjoy the rest of the video. All right, let's jump into the problem. Here's my first one. One number is 3 times another. The sum of their reciprocals is 6. Find the reciprocals. So I'm looking at this, and I see two parts here. This first sentence, one number is 3 times another, gives a relationship between the two things I'm trying to find. I'm trying to find one number, and I'm trying to find another number. But I know that one is 3 times another. So I'm calling the first one x, and as you can see, there's the answer for it, but ignore that for just a second, which means that the second number has to be 3x. Okay, that's what it means to be 3 times another, x and 3x. The second sentence then gives me the equation that I need to solve. And this one's actually pretty nice. It's kind of straightforward. It's there's not a lot hiding here, so that's pretty nice. It says the sum of their reciprocals is 6. Well, a sum is an addition problem, and a reciprocal is when you flip something over. So in this case, if you flip x, you get 1 over x, and if you do the reciprocal of 3x, you get 1 over 3x. And so we're just going to add those two things together, and the problem tells us they have to add up to 6. There's our equation. At this point, we're going to do the same kinds of things we did in the last section when we were solving equations. We are going to find a common denominator, we're going to multiply, and we're going to clean it up and see what happens. So in this case, x and 3x, the common denominator here is actually 3x. Remember, we're just trying to use as little as we possibly can so that if we multiply everything by the common denominator like I did over here, the denominators all go away. So 3x is our common denominator. And you can see that if I multiply 1 over x times 3x over 1, the x's will cancel, leaving just a 3. 1 over 3x times 3x over 1 just gives me 1 because it all goes away. And don't forget the 6. 6 times 3x gives me 18x. So I bring those pieces back. We have 3 plus 1 is equal to 18x, which of course means that 4 is equal to 18x. I divided both sides by 4 to get 4 over 18 is equal to x, and then I, of course, simplified my fraction to get 2 over 9. So there's my first number, 2 over 9. At this point, don't stop. It is kind of a common mistake. Sometimes I think people just get really excited. They're like, yes, I got an answer. And they forget that there's more that they need to do still. So the second number, we still need it. I just have to do 3 times it. 3 times 2/9 is 6 over 9. And I reduced my fraction to get 2/3. So there we go. There are my fractions. Now, pretty clearly, they do not add up to 6. 2 over 9 and 2/3 is nowhere near 6. But remember, it's the sum of their reciprocals that needs to add up. If you did flip them over and worked it out, they would add up to 6. So there's my first example. I'm going to do 2 more. All right, so let's continue on. I have another example, then we'll do one more after this. This one says, find 2 consecutive even integers, the sum of whose reciprocals is 3/4. So we're looking for consecutive even integers. So this is a little trick that I have taught in other classes, and basically even integers, they go up by 2 every time. So if you want them to be in a row, when we're trying to figure out what they're going to look like, it's going to be x and then x plus 2. And that's really nice, right? Because, as you can see, the answer is 2 and 4 here. We'll get to that in just a second. But whatever the first one is, the next one has to be 2 more. And so anytime you see consecutive even integers, or consecutive odd integers for that matter, you can always start by using x and then x plus 2. So that's a really great place to start because now we have expressions for both numbers. And then what we know is that if we add their reciprocals together, it equals 3/4. So here you can see I have my 1 over x plus 1 over x plus 2 is equal to 3/4. And then, this is where it gets messy. I have a lot of work to do. I need a common denominator. So unfortunately, this time, all 3 denominators are just completely different. The x and the x plus 2 look like they might be kind of the same, but they're not. X and x plus something are always different. They're just completely different things. So my common denominator is actually 4 times x plus 2. I need all three of those pieces to make my common denominator. So I went through and I multiplied each of those fractions by that common denominator. You can kind of see that work over here, and I highly recommend that you work through that yourself just to get really good at that. And so if you do the first fraction, you end up with 4 times x plus 2. The second fraction, the x plus 2's cancel, so you just get a 4x. And the third one, the 4's go away, and you are left with 3x times x plus 2. I then proceeded to get rid of all the parentheses, combine some like terms, and all that kind of good stuff. So I get 4x plus 8 plus 4x is equal to 3x squared plus 6x, right? Doing all my distributing here. I combined the 4x's to get 8x. Then I moved everything to one side. I chose to move everything over to the right-hand side because I had a positive 3x squared over there, and I like to keep my x squareds positive. It just makes the factoring that we're going to have to do here in a minute that much easier. So I subtracted the 8x. 6x minus 8x gave me the minus 2x, and I subtracted the 8. Once I got it here, I had to factor it, so I didn't have room to show you how I did the factoring. Again, we covered factoring earlier in the chapter or earlier in the book, so if you need that, go back and take a look at it. But it does factor to be x minus 2 times 3x plus 4. And what's nice is once you have a factor, since it's equal to 0, the only way the multiplication can equal 0 is if one of those parts is actually 0. So I split them up. X minus 2 could be 0, which gives me an answer of 2, which is what gave me this one, right? If x is 2, the second number, x plus 2, would have to be 4. Then that's going to actually be my answer. What happens with this other one, though? What's wrong with it? Well, let's take a look. We subtract 4, so we get 3x is equal to negative 4, and when we divide, we get x is a negative 4/3, which is a wonderful number. I have nothing against negative 4/3. But what it is not is an integer. Okay? Integers are all the nice numbers, positive and negative. No fractions allowed. So that doesn't fit the criteria for the problem. The problem wanted just consecutive integers, and since it's not an integer, it doesn't count. So we'll leave that one out, and our answer then is just 2 and 4. So there you go. One more example, it'll be a little bit more interesting. All right, so our last example is a little bit complicated, but it will be okay. We're going to set it up, we'll look at how to set it up, and then actually the solving this one's probably one of the nicest ones we've seen. So here's the problem. A boat which moves at 18 miles an hour in still water. So, middle of the lake, no wind, no current, the boat can move at 18 miles an hour. Travels 14 miles downstream in the same amount of time it takes to travel 10 miles upstream. Find the speed of the current. So we have this boat. It's going to be going against the current and with the current, and it will travel that same distance, it takes the same amount of time, but different distances. And so that's going to kind of be the key to this whole thing. It takes the same amount of time, and that's what we're going to really key in on. So this is just begging us to use the distance formula. Distance is equal to rate multiplied by time. Now, since we want two things to be equal here, we're going to try and get an equation. We know that the times are equal. Well, that means I need to solve the distance formula to get t by itself. So I just divided both sides by r. And I know that time is going to be equal to the distance divided by the rate. Okay, so how's that going to play out here when we have two different distances, or we have the boat going two different directions? Well, let's take a look. I made this little chart. Upstream, the distance is 10 miles, and that's given to us in the problem. Now, when you go upstream, the current is working against the boat. So the speed of the boat will be 18 minus whatever the speed of that current is. So we have 18 minus x, which means that the time to go upstream, which we're not given, but we're gonna get there. The time is then distance divided by the rate, 10 divided by 18 minus x. Going downstream goes a distance of 14 miles, and its rate now will be 18 plus x because the current will be pushing the boat along, so it'll be adding speed to the boat. So again, doing the same trick, taking the distance and dividing by the rate, the amount of time to go downstream for that trip is 14 over 18 plus x. And here's the key. Since we know that these two things take the same amount of time, these two things have to be equal to each other. So we really set up this distance problem twice in the table, once for upstream and once for downstream, but then we took the times and we just set them equal to each other because that's something we're given in the problem. So our common denominator then is 18 minus x times 18 plus x. I kind of got a little hasty here with my multiplying by the common denominator because I ran out of room on the board. That is the problem with this little tiny whiteboard. But anyway, if you multiply it out, you'll see that for the first fraction, you get 10 times 18 plus x. And on the other side, if you multiply it out, you get 14 times 18 minus x. Again, I'm multiplying by that common denominator to get rid of those denominators. So I expand the parentheses, I get 180 plus 10x is equal to 252 minus 14x. See, I added 14x to both sides to get 24x and subtracted the 180 to get 72. And if you finish up by dividing, you get that x is 3. So that's the speed of the current. And that's all we wanted on this one. So in this case, x actually is the answer to the problem. So that one's a little bit more complicated. It's definitely going to require you to work with this distance formula and manipulate it a little bit like we did here to get that time by itself. So I suggest you, reacquaint yourself with the distance formula and, you're going to see some problems like that and make sure you can do them. So have a great day.